Graphing rational functions, section 5, x and y intercepts. This is video number 5 in graphing rational functions. We've had 4 prior, obviously. In the first video, we covered steps 1 through 5 about how to find a vertical asymptote and how to state the domain. And then in the next video, we learned kind of an extension of that, the step 1 was factoring the numerator and denominator. If any of those factors cross out, that leaves you with a hole in the graph. And that hole in the graph, like the vertical asymptote, combined to be a restriction on your domain. Then in video number 3, we learned about horizontal asymptotes, and they were really very separate from those two. It has really nothing to do with the domain. If anything, it would have something to do with the range, but we don't really talk about range in this section. So the horizontal asymptotes were found by comparing the numerator and denominator highest power exponents, and there were 3 ways that could go. It could be top heavy, which in that case that meant there were no asymptotes, or they could be equal power, or it could be bottom heavy. In those cases there were horizontal asymptotes, and we discussed that in detail in that video. In the one case that there were no horizontal asymptotes, the top heavy case, that meant that there could be a slant asymptote, and by could be, it's only when the numerator exponent is exactly 1 higher than the denominator exponent. So this is video 5, and we're talking about our x and y intercepts, where our graph is going to cross the x and y axes. And this is really the last piece of the puzzle, because step number 10 is going to be, all right, now that you have all this information, graph. Step number 10 is going to be graph, and that's going to be the video after this. So we're just about ready to finally graph, which is funny because we've been doing, this is video number 5, and the chapter is called graphing, and we haven't graphed yet. So let's talk about x and y intercepts. X-intercepts, now first of all, let me draw just a little picture over here that our x-axis is the horizontal axis, and I'm hoping everybody already knows this, and our y-axis is our vertical axis. Say we have a graph going like this. Your x-intercept is the point that the graph crosses the x-axis, and your y-intercept is a point where the graph crosses the y-axis. And for your x-intercepts, y equals 0. What that means is that every coordinate on the x-axis, all these points have y values of 0. Like this is 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, negative 2, 0, negative 7, 0, and so on. Every point on the x-axis has a y value of 0. So your x-intercept coordinates will look something like some sort of number, comma, 0. The way to get them is you find the zeros of the numerator. And we've already done this in a previous chapter when we did rational expression inequalities, is you factor and solve the numerator. That gets you roots. Those are your x-intercepts, because roots are where you cross the x-axis. So that's really not new. Y-intercepts are where we cross the y-axis, and they have x values of 0. All the points on the y-axis have x values of 0. Like 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, negative 7, 0, negative 8, and so on. So the way to find the y-intercepts, and what that means, by the way, is that you're going to have a coordinate 0, comma, some number. That's going to be a y-intercept. The way to find the y-intercepts is you plug 0 in for all the x values and see what happens, because you have an x value of 0, so replace all your x's with zeros. See what happens. So let's look at a couple of examples. First one, g of x here equals x plus 3 over x minus 7. And we're starting off real basic here. There's no factoring to do. So solving the numerator is just setting it equal to 0 and solving. So your x-intercept would give you a coordinate of negative 3, comma, 0. Solving this up here would give you negative 3. Now what would make it 0? Negative 3 plus 3 would make it 0. Or you can think of it in terms of subtracting 3 on both sides, right? What solution do you get from an x plus 3 factor? You get a negative 3 solution. And you know it has a y value of 0 because it's on the x-axis. For a y-intercept, you're going to replace all your x's with zeros. So that would be 0 plus 3 over 0 minus 7 is 3 over negative 7. So that would be the value, an x value of 0, because you're on the y-axis, comma, negative 3 sevenths. Now, this is 3 over negative 7. I just floated the negative to the top because it's a little bit more proper, but it's okay if you're writing it as 3 over negative 7. That's essentially it. I mean, we'll add some factoring to it and everything, but for the most part, it's just factor and solve the top for x-intercepts, plug in 0, replace your x's with 0, and find your y-intercepts. Second example, right to the right, there's nothing really to do up top. X equals 0, so x equals 0. So your x-intercept is 0, comma 0. And your y-intercept, replacing 0 here and replacing 0 here, you end up with 0 over 0 plus 2 is 0 over 2, and 0 on top of anything is just 0. So you get 0, comma 0. And this isn't surprising because this coordinate 0, 0 is the origin. It's on both the x and the y axes. It's the only point on x and y axis. So if it's an x-intercept 0, 0, it's definitely also a y-intercept 0, 0 because it's on both axes. So it makes sense that if you have it for one, you're going to have it for both. H of x equals 7 over 2x minus 3. For the x-intercept here, what are we going to do with this? How do we solve for x in the numerator? Well, there is no x in the numerator, so you have no x-intercept. And we saw this with everything we've done so far today in this chapter with the vertical asymptotes, the holes, the horizontal asymptotes, the slant asymptotes. Sometimes there isn't one. And it's the same thing with the intercepts. It doesn't always have to cross the axes. So in this case, there is no x-intercept. There is a y-intercept, though. If we replace 0 here, that'd be 7 over 2 times 0 minus 3. 2 times 0 is 0, minus 3 is 7 over negative 3. And so that would be the coordinate 0, comma, negative 7 thirds. Again, I'm floating that negative to the top. All right, let's look at one now where we're going to do it all. We're going to find everything we've done so far to this point. Let's find a vertical asymptote. Let's find any holes. Let's find, well, let's state the domain. Then we can do any horizontal asymptotes. We can do any slant asymptotes. And then we can do the x-intercept and the y-intercept. And then this is everything here. And the next thing after this is just go to the graph and plot it. So first off, we start by factoring. We factor the top to get x plus 6 over x plus 2. And the bottom is x plus 6. We see our x plus 6's are going to cross out, and you're going to be left with x plus 2 over 1. So first, let's start with vertical asymptotes. Vertical asymptotes are what, solving for x in the bottom. If there's no x in the bottom, then there are no vertical asymptotes. Holes come from factors crossed out. Now we do have a hole. We have a hole at negative 6 because what would make x plus 6 0? Negative 6 would make x plus 6 0. And we find the y value of that by plugging negative 6 in for x into our reduced form, so negative 6 plus 2 over 1. We know the over 1 is not really necessary, just keeping it a fraction. But you don't have to do that if it's over 1. So negative 6 plus 2 is negative 4. So your domain is the restriction that comes from your vertical asymptotes. You don't have any, and from the x of the whole, you do have that. So your domain simply is negative infinity to negative 6, or negative 6 to positive infinity. Horizontal asymptotes, we go back to the original equation and compare powers. My top one is 2, my bottom is 1. So that's a top-heavy expression, so horizontal asymptotes, the answer would be none. But that means there could be a slant, and because we are 1 degree higher, then there definitely is a slant asymptote. So we have to do long division now. So x squared plus 8x plus 12 divided by x plus 6. What makes x squared times x does? That gives you x squared plus 6x. Change our signs. Leaves you with 2x plus 12. And how do I get x to be 2x? I multiply it by 2 is 2x plus 12. And this is a case where it actually is a factor of it. And so it's a perfect remainder of 0, but this x plus 2, because remember the remainder doesn't really matter. It's not always 0, but in this case it is. Your slant would be y equals x plus 2. And so now the final touch is what we are learning new in this video is the x and y intercepts. So our x-intercepts are solving the numerator, which comes from this x plus 2 here. And so that would give us negative 2 comma 0 for an x-intercept. And a y-intercept, if we replace 0 plus 2 over 1 would be simply 2. Right? It would be 0 plus 2 over 1 gives you 2 over 1. And so that's it. That's all the information you need. Now you can go over to a graph and start graphing it, but we're still just practicing the algebra part. We'll get to the graphing in the next video. See ya. Guys, there was